annoying things you can fix with 3D printing. Coming up right now. Right, welcome back to the joint where it's been a minute since I did anything here. And honestly, I don't know. My hobbies come and go. This is one of the hobbies. But I've got this annoying thing. My screen door handle here. Every time I go to try to open it, this reveal here just isn't deep enough for my fingers to get grabbed onto. So, today we're gonna fix that. I'm gonna model that thing and I'm gonna fix it and 3D print a new version that doesn't suck as bad. So let's get to it. All right, we are down here at the computer in the new office area. I still live in the same house, just the joint keeps moving around because, you know, life keeps happening. I need to move it here, or I need to move it there, I need to move whatever. Welcome to the new joint. Anyway, so I've got my piece here. We're gonna use the old calipers. And we're gonna take some measurements of this guy. And then we're going to jump into the computer here and we're going to model it up. Now the issue I have with this is that you try to grab this and this lip here is not very deep. So all I'm really probably going to do is just remodel this exactly and then just maybe deepen this up, maybe add a little bit of a curve back or a chamfer backwards or something. That way it gives your fingers more purchase when you go to open it. So, first things first though, I need to indulge my spicy water addiction by pouring out some Pamplemousse LaCroix. Man, that stuff is good. Anyway, let's get to measuring. Alright, when it comes to modeling something for this kind of thing, it's always good to have a notebook and a pen just hanging around because I'm going to just kind of sketch out the shape, generally speaking, and then I'll take some measurements and I'll just kind of jot it down. And this is easy enough that I can actually kind of just slap it down and trace it, and that's probably what I'm gonna do here is just trace it and then put some measurements on it. So we're gonna do that right here, right now. It's off camera, you can't see, but that's fine. You don't need to see this part because this is kind of a third grade thing here. And it's not going to be perfect, but it doesn't have to be perfect. I'll fix that all in the model. Oh, and the other thing I'm going to do is the location of the screw holes because that's kind of going to be important. Those got to line up right. The spicy water's coming back up. Alright, folks. Here's what we got. We got this, and then I'm going to take some measurements with the calipers as far as the thicknesses and whatnot. So we got this thickness is, how about we change that to millimeters? 3. Zero that bad boy. Oh, that is 3 on the nuts. Dang, 3.0. So, this is 3 millimeters. And the overall thickness is, let's just say, 9 millimeters. Which would mean this reveal be about 6 millimeters. Overall is 9 millimeters. So I'm not taking the best notes, just sloppily jotting this stuff down. If you're gonna 3D print something, or you're gonna model something like this, it doesn't have to be pretty. It's pretty when it goes in the computer. So now it's kind of got a weird shape to it, and I don't know if I really want to maintain that weird shape. It's 54, so I'm gonna say an overall width of 55. Just because. And then, when it comes to the thin part, that needs to match. This here, that needs to match. So, that's going to be interesting. I have to eyeball that. Let's just say 25. That's close enough. That would mean this is going to be 30. And then I'm going to make this. Let's see, do I have enough? How thick is this guy? That's 4. So we're going to make this 4 all the way around. And then, what's the screw hole diameter? That would be a 5. And then it's got a countersunk portion of it for where the screw heads are sitting recessed. Let's just say 10. And that basically goes all the way through. So this is, what, 3 millimeters thick. So in section, that's going to look like this. Something like that, right there. So with this, I think I've got pretty much all the information that I need to move to the computer. So I think we're gonna just do that. We're gonna move to the computer, get things going, and then we'll get this on the printer and print it out and see how it fits. This is gonna be probably a couple hours of waiting for me, but for you, it's gonna be pretty instantaneous once I get it modeled. So let's jump to the computer. Okay, we're in CAD. And this is not a CAD software that any of you probably will ever even see. This is what I use at work. I could use Fusion 360, but I'm lazy, and I just know this so much better. So this is what I'm doing. You know, sue me, whatever. It is what it is. So we're gonna switch to here, and we're gonna jump right into it. So I've got a 55. You know what I didn't measure is the overall length. What is the overall length of this bad boy? 102. Let's make it 102. 102. 102. And then I need to measure the distance between the centers of these freaking holes here. That's gonna be... Oh, actually, I could just do that here. Let me just use the path. I'm gonna use the path. I'm gonna get a more accurate reading. 70. 75. Let's say 76. 76. Center to center. Between the holes. 76. Okay, so let's begin at the beginning and just draw a 55 by 102 rectangle. A rectangle. I'm gonna make it red. Not that red, this red. So 55 by 102. Get zoomed in here. And then, you know, the next thing I didn't measure is the distance, so I needed to measure this distance, I need to measure this distance. Sometimes I take measurements and I just completely forget everything that I need, you know, whatever. So we're gonna say it is 10.5 off of this 25 line. So we're gonna say, boom, 10.5. Okay, anyway, I got my notes, I got my measurements. So, the next thing we're gonna say is that we need a line that is 25 from here. This minus 25. Okay, so this is going to be the 3 millimeter thick portion. So what I'm gonna do is actually draw this 25 by 102. We're gonna just go ahead and extrude that to 3, not both directions, 3 millimeters. All right, and then the whole thing was 9 millimeters. So let's rotate a little bit here. Make sure that I'm recording. All right, so we're gonna make this guy. And we're gonna say 9 millimeters. There we go. So the screen door like frame sits here, and then the handle will be on this side. So what I want now is to create this cup where your fingers go right here. And again, I don't think I'm gonna go with the fancy like shape. I'm just gonna do a nice, let's see, how thick is this? Can I get a good measurement of that? That is highly unlikely. But I'm gonna say it's about 2. So we're gonna do something here. I'm gonna put a shell here. We're gonna shell this solid like this, not that one. Where's the tool? Shell thickness of 4. That's not the tool that I want. This is the tool I want. Alright, so we're gonna shell this solid. We're gonna say we want this to be 4. Here, like that. So there's our shell. And then the thickness of the bottom here is kind of like 2 millimeters. So we're gonna do this and say that. We're gonna say this minus 2. Alright, so that gives us our basic shape. And now what we're gonna do is put in the holes. So we're gonna draw a line here. We're gonna go over 10.5. And then they are going to be 76 apart. 76 76. And then we're gonna go like this, divided by 2. That way we put them right in the middle. And they need to be on this side. So here's what we are going to do. Now, the thing with 3D printing is that I don't like to go chamfer down to a point because sometimes it doesn't really hold that well. But that's alright. I think I'm going to give it a shot and see what happens. Because this thing is 3 millimeters thick. So it should be alright. Should be alright. However, I gotta rotate this a little bit because this is annoying me. That way I can go top view, and then let's orient it like this. There we go. So what I can do is move these to right here, and then I can put in a cone solid. Base radius is 5. Height is 3. The top, radius 2.5 and 5. So I should be able to go like this. What's going on here? Alright, we're not doing it that way. Alright, so what I'm gonna do is put in a 5 millimeter diameter circle. And we're going to extrude those up like that and like that. And I'm going to move them down just a bit to make sure that they cut all the way through. Oh crap, I didn't get this one. Okay, and then we're just going to subtract these from this. And then what I'm going to do, it was basically just a five by 3 chamfer. Distance 1 is 5, distance 2 is 3. That is what I wanted. Right? No. That's not what I wanted. It was overall. So it's going to be 2.5. 2.5. Because I want the top diameter to be 10. And I want the bottom diameter to be 5. Perfect. So here is our basic shape. It is modeled very similarly to what this currently is, which I don't like. So let me switch my view so you can kind of sort of get an idea what we're looking at, and then we're going to make some changes. Let's get rid of a bunch of extra construction line stuff. I should only have 2 elements. Okay, so here's what we're left with. Now, this depth here, let's just measure it and see if it matches. So I'm measuring about 6 millimeters deep. This is 7 millimeters deep, so it's a little bit deeper, but I'm going to change it just a little bit because I want it to kind of curl back, so when you grab it, it kind of is angled up towards your fingers to where they don't slip out. They tend to want to pull in. So we're going to do that right now. So in order to do this, I'm gonna basically kind of sort of start over. So I'm gonna start here, and I'm gonna extrude this dude up 2 millimeters to here. That gives me the base. And then I am going to put in a shape right here for the inside. So that should be right there. That is correct. Okay, so what I'm gonna do, is this. We are going to extrude this up 7 and over, let's just say 3. Let's give that a shot. So if we go here, we need to make sure that it's not orthogonal. We're going to extrude this up 7 and over 3. Up 7 over 3. Alright, so that way we wind up with something kind of like this. But remember, I wanted it to be a little bit deeper too, so let's go up 10. Let's try 10. Up 10. Whoops. Oh, come on. And 7 and 3, I kind of liked that ratio. Let's see what that would be with 10. So let me just do a little bit of math here. 10, 7 to 3 is the same as 10 to something. So that would be 3 times 10 over 7, 4.28. So let's just say 10 to 4. It's roughly the same. It's not quite the same, but it's roughly, it's actually 10 to 3, yeah, 10 to 4. Let's just do 10 to 4. See what that looks like. 10 and 4. Side, 10 and 4. And let's see what we got going on here. Oh yeah, I kind of like that. I kind of like that. And you know, guys, I'm not going to win awards for aesthetics here. This is purely a functional piece of hardware. So if it doesn't look the best, I'm gonna say I don't really care. So let's do this by subtracting this from this. And that should give us a shape here. And then the only other thing I don't think I like is this little overhang right here. So let's just kind of sort of lop that off by doing this. Alright, and then we're gonna go something like this. Subtract that bad boy. And let's see what that looks like. Right view. Oh yeah. Oh yeah, that looks okay. That looks okay. So this is our basic shape now. Let's kind of make it all into one. That way we can pretty it up a little bit. So I'm going to put some chamfers on here just to make it a little less sharp. These are just going to be nice and easy 1mm chamfers. Oh yeah, and then let's put something all the way around on the inside of here. And then let's put something here. And I just realized we have made a mistake because where the screen door sits, right view, right here, this has to be a right angle, so we need to notch that back out. And then we need to make sure that we have enough meat there Don't mind the noises upstairs. The dogs are just going crazy. It's fine. Get dogs, they said. It'll be fun. Dogs suck. Dogs are fun if it's somebody else's dog. Anyway, not to just completely rant on dogs. Okay, so I think this is looking pretty good. I want to look at this and see how much meat we have here. I may need to add something. I may need to stretch this. What do we got going on here? So if I measure this guy from here, that's 2.5 in this direction. What is it if we go roughly perpendicular? Let's go here. Roughly 2. Yeah, that's probably thick enough. That's probably thick enough, I think. So let's change the view style and see what we got going on here. Illustration, modeling. So this is kind of what we've worked up to this point. We got this piece that looks like this. Looks like this. And I think that's going to do it. So let me get this exported and then get it into the slicer, and then we'll send it to the printer and print it. Stand by. Alright, so here we are in the slicer. I sliced this up and I didn't realize that I wasn't recording. So rather than stop it, I'm just going to show you what I got here. So right now the printer is warming up, but if we look at the part, this is our part that I brought in, and I had to set up my settings to where I got the appropriate supports to support this guy, and then just make sure everything seems fine. Seemed like it was good to go. So here we are at the device. It is currently warming up, and once it gets warmed up and going, it will be printing, and then we'll meet back up at the back door to install the thing and see how it works out. As you can see from the video here, it's going to be a red part, which I'm sure my wife is going to be thrilled about. But if it works and it fits and I like it, I can always buy some black filament and reprint it. So it's going to take about 48 minutes. I will include the time-lapse video of this thing printing, and then we will meet back up at the back door. Alright, here we go. Here is the finished product. Let me get it off of here. And let's get that guy off of here. We gotta get the supports off, and then we will go install it on the door. So let's get these supports off. Alright. These supports are off, so let's go put it on the door. See how this works. This PLA I got real cheap, and it printed like crap. It's not the printer's fault, it's my fault for buying crap PLA. Hold that. It's recording. I've got this, and I'm going to put it on the door. I gotta take these screws out. This is the moment of truth when I find out whether or not my CAD modeling skills are legit. Whoa. And it looks to me like we're gonna be good to go. So we'll get one screw going. Get it there. Come on. There we go. Gotcha. And the next screw going. Get it in there. There we go. Oh wow, I like that so much better. Alright, and it looks just like it did in the CAD model because it's red. And I can tell you, Mrs. Justin's joint is gonna be so thrilled. that thing is red. However, it is night and day better than the one that was there before. Night and day better than the one that was there before. See, the problem is the dogs have barreled through this dang door so many times that it's bent right here. And just over the course of time, it would get to where, you know, this just bends more and more when you use these handles. And there wasn't enough grab here. So with that, we're calling this project a win. I'll remake that in black when I get some better PLA. And until next time, right here in Justin's Joint, we will see you guys later.